If you're looking for a content explaining how to easily collect your Prometheus metrics using the OpenTelemetry operator, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is part of the OpenTelemetry series where we had already lots of episodes. How to create custom metrics, how to instrument your code, how to collect logs using the OpenTelemetry collector, the value of ADA, the value of the OpenTelemetry operator, and more. Today's episode will be focused on a recent update done by the OpenTelemetry community, and especially on the OpenTelemetry operator, and I'm referring to the Target Allocator. During the last KubeCon North America, I had the chance to briefly interview Anthony Marbella, maintainer of the operator, and he took a few minutes to explain the concepts around the Target Allocator. Today, I will try to explain in details this amazing feature. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We'll start with an introduction related to the Prometheus receiver of the OpenTelemetry collector. Then we will remind the powerful CRDs introduced by the Prometheus operator that simplify our journey when we need to add new exporters in our cluster and using the CRD, ServiceMonitor and PodMonitor. Last, we will explain the value of the Target Allocator. Like explained in many episodes, the OpenTelemetry collector is a perfect component that will be in charge of collecting metrics, traces, logs that will process them and forward them to one or several backends. You may ask yourself, what kind of tasks should we achieve with the collector? Well, this means that you're not paying attention to the previous video published on this channel. So let me briefly remind you a few use cases. So processing will help us to convert, reduce the cardinality of our metrics, manage the sampling decisions of our distributed traces, enrich the data by adding extra metadata on our metrics, traces, and logs. When it comes to collect custom metrics with the collector, we can achieve it using several receivers. Of course, ODOTLP receiver, to receive metrics produced by our application with the help of the OpenTelemetry instrumentation library. Then we have StatsD, we have Prometheus receiver, and of course there are plenty of metrics receiver that are designed to collect specific metrics on a given technology like IaaS, like host receiver, and so on. In the case of the OpenTelemetry and StatsD receiver, the collector will be listening for incoming metrics. In the case of Prometheus receiver, the collector will reach out to Prometheus exporters to collect the metrics. This is defined in the settings of the Prometheus receiver, where we configure a scrap config. In the scrap config of the Prometheus receiver, or in fact, in Prometheus in general, we can define several jobs collecting metrics from various endpoints. The endpoints can be defined using either a static config, where we would define the URL or the host of the various Prometheus exporters. And Prometheus includes several service discovery or for specific technology. Of course, we have the Kubernetes SD config, the OVH SD config, EC2, Docker, and so on. Each job defined in our scrap config will be able to configure the scrap interval, so how often we're going to scrap, the timeout, the duration, the maximum duration that we tolerate to reach out to the exporter, the metric path, by default is going to be /metrics, the protocol used with the help of schema, and by default, it's going to be set to HTTP. And we have also params, where we can also pass through few URL parameters that may be required to reach out to the Prometheus exporters. And of course, if you have enabled TLS or if you have enabled basic notifications, you can configure that with the basic notification or the TLS settings. So here is a link to the documentation of Prometheus on the scrap config. Of course, the configuration depends on the component used to discover our Prometheus endpoint. But let's have a look at the most common configurations that we may need to use, especially in a Kubernetes environment. So there will be the static config and the Kubernetes SD config. Static config is from far the most easiest one, where we would only need to define the lists of targets that we want to scrap. And we also have the options to add static labels to all the metrics collected from those endpoints. The Kubernetes SD config will interact with the Kubernetes API to get the endpoints to scrap based on the annotations, the service names, the pod name, and so on. We need to specify what kind of components will be targeted by the scrap config with the help of a role. So in the Kubernetes SD config, you have several roles. You could be pod to target only pods, services to target services, node, of course, endpoints, ingress, and more. On each role, you can filter to specific namespace by using this filter, namespace, and then names, and you can put the list of the namespace that you want to limit the scrap config. Each role will provide a set of metadata that we could attach to our relabel config, which means if we are collecting the role pod, naturally lots of metadata will be automatically included. So here is the list. So you can have the meta Kubernetes namespace, meta Kubernetes pod name, the pod IP, the labels, the annotations, and so on and so forth. Then we can use the relabel config to configure the scrap config based on parameters, allowing us to reach out to that endpoints. We can technically replace, for example, the address, so __address__, which is the address of the exporter. By default, it will be set to the hosts and the port. Then we have the metric path, we can replace it, and also the scheme, so HTTP or HTTPS. We can also, with the relabel config, do remove metrics having specific names, reduce the cardinality of the metrics by dropping labels, renaming labels, and so on and so forth. The relabel config has various options. So we have the source_label that will precise which field we will do any kind of operations. We have the target_label that which precise which label would have the change that we just are applying. We have regex to extract value from a label, replacement. It is required when you use regex to precise which group we want to use in the replacements. And of course, we have actions defining which type of action we want to achieve. And there are several actions available. We have the lowercase, the uppercase. We have keep to define which endpoints we want to keep in the scrap config, drop to drop targets that are, for example, that are respect not a given regular expressions. We have label drop to drop labels from the metrics collected. We have label keep to keep only specific labels from that exporter. In the scrap config, all the informations are available and would start with __meta _ Kubernetes _ pod _ annotations. For example, if we're targeting annotations. So you can see that all the dot from our annotations would be replaced by an underscore. All the labels and annotations are available. So __ Kubernetes _ pod annotations, and then the name of your annotations, or same thing for the label. So here _meta _ Kubernetes _ pod _ label, and then the name of your label. Again, keep in mind that the dot will be replaced by underscore. For example, in Kubernetes, we are used to set Prometheus annotations onto our workload. So we have the Prometheus.io port, Prometheus.io scrap to see if it's true or false. We have the path, and we have also a lot of things about TLS and notifications, which means we can create a scrap config collecting all the pods having those annotations. We first need to keep all the pods where the source label Prometheus.io scrap is equal to true. So if you want to do that, we could express this with here in action keep. So say we want to keep, and then we say the regex is true. So there is more the value is true, and then the source label is the pod annotation Prometheus.io scrap. Every pod having this annotation equals true will be considered to be scrapped. Then we want to change the address, because in the annotation you have the notion of the port, the metric path, the scheme could be also replaced. So we can do that also based on annotation. So we can do the following actions. So we're going to use a replace, use regex to say if there's HTTPS, then we will replace it, and we will replace the field schema. Then we can do the same thing for the address, so the URL of our exporter. Then potentially we probably want to add to our metrics Kubernetes metadata. This will be done in few steps. First, we may want to add all the labels available in our deployments, in our pod. Maybe there are lots of relevant information. We probably want to add that to our metrics. So for this, we're going to use the label map, and we're going to extract everything which is in the label of the pods. Again, this is a great way of enriching the metrics, but be cautious, because adding all the labels of your workload will just increase the cardinality of the metrics, and then it will be more expensive to store. So try to limit yourself to only the useful labels that you will need to filter or do any queries in your backend. Then we can rename default Prometheus label. If you remember in the role pod, there's already some fields like the Kubernetes underscore namespace or the Kubernetes underscore pod name, and those maybe you want to replace with a proper name. For example, here we do replace, we use the source Kubernetes namespace, and we rename it with Kubernetes underscore namespace. We can do the same thing, of course, with the pod name. So this is mainly helpful to scrap metrics from all the exporters with having the Prometheus annotations. But imagine that you can also use the scrap config to reduce the cost of your metrics. For example, reduce the number of metrics that may not be useful, or reduce the number of labels to reduce the cardinality of the metrics. So for this, we're going to do like a drop. For example, all the metrics that has the name of the metrics underscore name, so that's the source label. And we can say, oh, for all the metrics having that name, we're going to drop it. We can also do the same thing, but instead of a real name of a metrics, we can say all the metrics starting with go underscore star, we want to drop it. So we can do the same thing, use the drop actions, and see here we use the regex with go underscore star. This will be dropped. And to reduce the cardinality, basically it means removing labels. We can also use the scrap config. So here we use action label drop. And you can see here I'm precising in the regex that container ID will be dropped. I can do the same thing for PID and so on. Scrap config are something that we are used to configure when collecting data from a bare metal environment. But in Kubernetes, we often deploy the Prometheus operator. In small note, the Prometheus operator is already pre-installed in some flavor, like OpenShift has the Prometheus operator pre-deployed. This operator introduces a smart way to dynamically add new exporters without having the need to modify our scrap config. This is possible when using the PodMonitor and the ServiceMonitor. In a Kubernetes environment, to add automatically metrics from pods or services exposing Prometheus data, we are not required to either add Prometheus annotations in our deployments or continuously updating the scrap config from our Prometheus server. In fact, in the case of the Prometheus, the scrap config is a config map, which is in fact compressed. So it's quite clunky to modify that scrap config. That is the reason the Prometheus community has built specific CRDs that will help us to add dynamically new Prometheus exporters to Prometheus. This is technically possible with the help of the CRD ServiceMonitor and PodMonitor. And one small note, the operator includes also a CRD called scrap config, allowing us to dynamically add new scrap config in Prometheus. So let's have a look at two of those main CRD, the service and the PodMonitor. The difference between the PodMonitor and the ServiceMonitor are quite simple. The ServiceMonitor will target endpoints and services defined in our Kubernetes cluster. If your pod are exposed by a service having the port for your app and the Prometheus exporter, then we can easily create a service monitor that will automatically target all the pods that are behind this service. Similar to a Kubernetes service, the service monitor will select your service based on a selector. You will filter your service applying the right label selector. Then many of our services expose several ports. So we need to define which port is holding our Prometheus exporter. This is possible with the help of endpoints, where we'll specify not the port number, but the name of the port defined in our Kubernetes service. Endpoint is also allowing us to create relabeling config to drop or reduce the number of labels that are exposed in this specific Prometheus exporter. This is possible with the property metric relabeling. For example, so here is an example of a service monitor where we have an endpoint with some relabeling configurations. The PodMonitor is a bit similar to the service monitor, but as you may expect, it will only target pods. So you will select the pods by applying, again, a selector based on label. Then we won't define endpoints, but the pod metric endpoints that will have the port name defined in our pod template that is exposing the Prometheus metrics. We can also customize the path with the path property. And similar to the service monitor, you will be able to create your relabeling rules with the help of pod metric endpoints. So for example, here is an example of a pod monitor where we precise the pod metric endpoints, the port, and the relabeling configurations. To simplify the deployments of our collector, the OpenTelemetry community has worked on an operator designed for Kubernetes to simplify first the deployments of our collector, the configuration of the instrumentation settings like the sampling decisions that we would like to inject automatically in our workload. If you want to learn more about the operator, check the episode related to it. Previously, collecting Prometheus metrics required to configure the right script config in our Prometheus receiver. Now, this is completely over. To simplify the configuration of the Prometheus receiver, the OpenTelemetry collector community has built an amazing feature that will create the right script config based on PodMonitor and ServiceMonitor deployed in our cluster. This feature is named the Target Allocator. The Target Allocator is a property in the CRD OpenTelemetry collector. To enable it, we will simply need to add here Target Allocator enabled equal true. Once enabled, the operator will deploy one deployment with one replica with the Target Allocator. The Target Allocator will be named, or the deployment will be named collector CRD name under dash Target Allocator. It will also deploy a service with, again, the same name, so the collector CRD name that you have defined, and a dash Target Allocator. The Target Allocator requires a service account. Normally, the operator should create it for you. If not, don't forget to create the service account, having the right privileges to achieve the script config that you have defined in your script config. The service account needs to be named the collector CRD name that you have defined dash collector. Once enabled, the Target Allocator will take your script config and run it in the Target Allocator. So at the end, the Prometheus receiver settings will be replaced completely using the http_sd_config. And this configuration discovery of Prometheus is basically the Prometheus is sending an HTTP request to an endpoint to get the targets that he needs to scrap. So the collector, the Prometheus receiver, will send an HTTP request to the allocator to get the targets to scrap. One important aspect is that the Target Allocator is a feature that is only compatible with specific deployment modes of our collector, the stateful set and the deployments. The Target Allocator will discover the targets to scrap based on the scrap config that we've defined in the collector, and also the available collectors if you have several replica, and will assign a list of targets for each collector pods. Then Each collector at the end will send a query to the target allocator to get the endpoints, and then they will send that query to the right Prometheus exporter. In the collector CRD, the target allocator has specific settings to enable the Prometheus CRD. So if you enable the Prometheus CRD, the target allocator will discover PodMonitor and ServiceMonitor deployed in the cluster. Of course, you need to assign the right cluster role to have access to those new resources. So here is the minimum cluster role that you need to add to the target allocator service account. So you can see here it has access, or I can see the ServiceMonitor and the PodMonitor. So enabling the Prometheus CRD support will make our life easier because we won't need to define any complex scrap config within our Prometheus receiver anymore. The great thing with the target allocator is that it's also providing endpoints at the target allocator service for debugging perspective. So for example, it exposed few paths. We have the /scrap config to get the scrap config that it has generated, /jobs to get all the jobs that has been generated by the target allocator. And then if you want to see the targets for each job, you will have to send the query /jobs, the ID of the job and the targets. And also, if you want to see the targets for each individual collectors, you have /jobs, the job ID, and targets, and then you precise the ID of the collector defined in the target allocator. That's it for today's episode related to the target allocator. As you can see, the target allocator is a great improvement for when using the collector in a Kubernetes environment, because we don't have to define those complicated scrap configuration rules. Again, I think using it without the support of Prometheus CRD is interesting, but the value is clearly when you enable the Prometheus CR support, because then you just need to deploy the naturally PodMonitors and ServiceMonitor, and the target allocator will define the right scrap configurations to our collectors. The also great advantage I would say is that from a moment you have several replica behind your stateful sets or deployments of your collectors to load balance or split the scraps, the collection of metrics on the various collectors. So I think it's a smart way, especially if you have lots of metrics to collect within your cluster. Again, like explained, the scrap configuration is great because you can relabel and modify and drop labels, but again, keep in mind that you can still do that utilizing the ServiceMonitor and the PodMonitor because you have the relabeling configuration properties. If you're looking for the tutorial, there will be a dedicated episode with tutorials on the target allocator, where we're going to look at the target allocator services, the deployments, what you need to define as a minimum configuration as a Prometheus receiver in your collector to take all the benefits of the target allocator support. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.